Now this problem, this says we have a loop. This loop is kept in xy plane. So this is my x-axis and this is my y-axis. This loop carries a current I naught, this P, S, R, Q and then P. So this loop carries a current I naught and the direction of current is shown here. So this is S to R, R to Q, Q to P, P to S. So this is the current direction you have. Now the question says there exists a magnetic field B and this is directed along this axis. So that is a diagonal axis. So you have 45-degree angle. So magnetic field makes an angle 45-degree with the x-axis. This means I can calculate what is the x component of magnetic field and y component of the magnetic field. We can calculate this one. Are you getting or not? So you see the question gives you the magnetic field. So I can calculate. Let us calculate this one first. So I have been given. So we have been given magnetic field x component and y component can be calculated easily. So this is my B naught. So I can calculate this will be my Bx and this will be my By and this angle is theta that is given to you 45 degrees. So theta is equals to 45 degree and now let us say this is my x-axis, this is my y-axis. X-axis I have unit vector I and along the y-axis I have unit vector z. Are you getting or not? So now I can write Bx. Bx is nothing but B naught cos 45 degrees. So B naught cos 45 is B naught by root 2. So this is Bx. Similarly, I can write B by, that is B naught sin 45 and sin 45 is again 1 by root 2. So this is B naught by root 2. So now I can write magnetic field B in a vector form, that is Bxi plus Byj, B naught by root 2 I plus B naught by root 2j. So this is B naught x plus B naught y. Are you getting or not? So I can take common also. So if I take B naught by root 2 common, so simply this becomes I plus j. Simple. Now the question says at t is equals to 0, frame is position as shown in the figure. And the mass of this frame is m. Each side of the frame has mass m and length l. So this length is L, this length is L, so this is a square. What is the torque about O acting on the frame due to the magnetic field? So we have to find torque about O. So what we have to find? Torque about O. So we have to find torque about O. How will you find? So if you remember, so this is torque about O. So if you remember, we have a formula in magnetic field. Torque is given by mu cross B. So this is mu cross B. And what is mu? If you remember, this is mu is equals to number of turns into current into I, area vector. So this is a mu vector. Now you see, define n in this case is 1. This is a one loop case, so the n is 1. So I can write mu is equals to n is simply 1 and current is I, that is given to you, I naught basically. So current is I naught, that is given to you, and cross A. What is the area vector? Area is magnitude of area is A square. And now if you make the thumb rule, so this goes something like this side, so this thumb goes inside. Are you getting or not? So if you hold your thumb such that, if you hold your hand in such a way so that current shows you the curling direction, so the Z will be, the magnetic field area vector will be inward. Are you getting or not? So area vector, so if you clearly see the area vector is inside. To getting, so area vector is inside. This means this is my x, this is my y. So this is x, this is y, and then this is my z. So I can say x, y, z axis is somewhere here. So this is my x, and this is y. So if you have x cross y, so this will come outside. X cross y will come outside. So this is my z axis. So area vector is basically minus k axis. So a square, and magnitude of area vector is a square, and the direction will be minus k. So finding torque is now easy. We can use the vector formula. Torque is equals to mu cross b, and mu I know, that is I naught a square and minus and vector k. So mu cross b, and b is what? B is nothing but b naught by root 2. So So I can write the same thing, b naught by root 2, and this is I plus j. Now we can use this formula. So I will have v naught I naught a square, this divided by root 2. Are you getting or not? And now this is a minus sign there. Now k cross I, what is this? So if you remember, I is a k. So this is I, this is j, this is k. I cross j, k. J cross k, I. Similarly, we have to find k cross I. So this is k cross I. You are going in the same direction. So k cross I, that will give you j. So this is k cross I is j. And k cross j is what? This is going opposite. So k cross j is minus I. So this is minus I. Now if you observe the minus sign, you will have, so if you observe the minus sign, you will have, so you will be having b naught I naught a square divided by root 2, and this becomes I minus j. Are you getting or not? So this is torque. So the first point, you have to find torque, that is b naught I naught a square by root 2 I minus j. So what is the magnitude of torque? Somebody asked, what is the magnitude of torque? So this is magnitude of this, and I minus j. So you will have b naught I naught a square by root 2, and the magnitude of I minus j is root 2. Are you getting or not? So you will simply having b naught I naught a square. So this is the torque. What is the axis of torque? That is I minus j. So next part also asked. So you see, this is the torque v naught I naught a square, and this is, I am writing L square, that is basically a square. Now question also ask, given that the moment of inertia of frame about an axis that is perpendicular and passes through center is 4 by 3 ml square. What is the rotation axis? I minus j. So let us try to locate the rotation axis. So this ring will rotate about a axis, that is I minus j. So rotation axis I can say. So torque is along the axis I minus j. So rotation will happen along the axis I minus j. So rotation axis is and this is nothing but I minus j. Are you getting or not? So this is rotation axis. So if you try to locate what is I minus j, so you can see here. So this is your loop. So this one is your loop. This side also you have. So this side you have, this side also you have. Same thing. So this is your axis, this is rotation axis. Now I minus j. So I vector I will have this side, and minus j vector I will have this side, and both are equal magnitude. So this means this will pass through this diagonal. Are you getting? So this will pass through this diagonal. So this is my rotation axis. So the axis of rotation is this. So this is the axis of rotation. Are you getting or not? So this is the axis of, and this will orient in this way. Are you getting? So because this is plus I and this is minus j, so we will have I minus j vector is something like this. So this is I minus j vector. Are you getting or not? So this is my rotation axis. So this is basically it will rotate. It will rotate along the diagonal. Are you getting or not? So it will rotate along diagonal. What is the name? So this diagonal is SQ. So this diagonal is SQ. So it will rotate along diagonal SQ. So it will rotate. So it will rotate along diagonal SQ. Are you getting? So it will rotate along diagonal SQ. Now if somebody asks what will be the direction of rotation, either it will rotate something like this or it will rotate something like this. So you see this one, if this rotates, then I will have a rotation omega in the downward direction. That should be because my torque is in this direction. So my torque direction is this. So this is the direction of torque. So this is the direction of torque. So I should have direction of omega also in this way. So this is the direction of torque, so it should be direction of omega. So this is possible only if I have something this kind of situation. This is not possible. If it rotates in this way, the omega will be directed up. So I can now know this will rotate in this fashion. So this own fashion. That is basically anti-clockwise. So it will rotate anti-clockwise. That is also obvious. So it will rotate anti-clockwise. Now I want to find what is the moment of inertia about SQ. So I know the moment of inertia that is perpendicular to this plane, that is, let us call this axis and this axis. These are two perpendicular axes. Now I can apply perpendicular axis theorem. So these two axes are basically perpendicular. So I can apply perpendicular axis. So this is PQRS. So if I apply perpendicular axis theorem, IZ is equals to IPQ plus I, and this is PQ naught, this is SQ. So this is SQ. So this is SQ plus IRP, and both is equal. So now I can write IZ is equals to basically 2 times ISQ. So this implies ISQ is nothing but IZ divided by 2, and the IZ is given to you. IZ is basically 3 by 4 ml, 4 by 3 ml square, and this length is L. Okay, I am taking this length as A, so the diagonal, so the side length is A. So this becomes 4 by 3 MA square. So this becomes 4 by 3 MA square. So IZ is nothing but 1 by 2 times ISQ. So this is ISQ. So ISQ is equals to 1 by 2, and this times IZ, that is 4 by 3 ml square, and in place of A, L, I am writing A. So this is 2 by 3 MA square. So if I know torque, I can find alpha. So let us say alpha is what? So alpha I will have, that is torque by moment of inertia, and this is the torque about SQ. So that torque is along SQ, so I have to get moment of inertia again along SQ, and this is the torque along SQ. So torque is, I have already calculated this torque. So this value is magnitude wise B naught I naught A square. So B naught I naught A square. So this is B naught I naught A square. This is torque divided by I, that is 2 by 3 MA square. So this becomes 3 by 2 B naught I naught by M. So this is the torque. So now I can calculate theta. So theta is equals to theta naught. So initial theta is 0 plus a half AT square, and alpha is, we have already calculated alpha. This value comes out to be 3 by 2 B naught I naught by M, and time is given to you, that is delta T whole square. So this is the rotation angle. So you see rotation of this, so loop you will have, so 3 by 4 B naught I naught delta T whole square, and this divided by, you will have M. So this is the final answer.